Okay. I was looking through the questions that many of you wrote last time about, what should be the questions we ask about water, and many of you asked, was there ever an ocean on Mars? And given what we just talked about with the valley networks, why might we expect that there would be an ocean on Mars at some point?
There must be like a water source for these.
Okay, there must be a water source for the precipitation.
And all the rivers have to end somewhere.
And all the rivers have to end somewhere, so, cycle of life kind of thing, water cycle. So if there were rivers, we would perhaps have expected there to be an ocean. But
you could just find a bunch of dark, wet soil or dirt or something.
Yeah, that's more along the lines of, what's the situation with water on Mars now? And we will certainly talk about that next week, or maybe we'll have to go into the following week. But yeah, there's evidence for briny subsurface water, and we'll talk about that. The issues with ocean on Mars, though, it's been a controversial topic for a long time, and I would suggest that although the tide is turning a little bit, there's still not complete uniformity, complete agreement among Mars geologists that there is convincing evidence that Mars had an ocean in the past. So what I wanted to do is just talk about a little bit of some of that debate and where this area is going. Whether Mars ever looked like this, I'm not sure. But, it could be that those rivers went somewhere, but whether it would be an open water tropical ocean like this is an unsettled question. Could be that all those rivers went to an ice-covered Arctic Sea. It's a question of, if there was an ocean, how long would that ocean have been there, and so forth. So let me run through this a little bit more quickly because I want to pull up a video at the end. Okay, so this is what we see of Mars today. This is Endeavour Crater, where Opportunity now is. I won't even bother turning on the lights. It's dry, it's dusty. It is not very tropical, certainly, and not. You don't get visions of tropical beaches with palm trees and hammocks when you think about Mars today. Same thing here. This is just from the Spirit rover before it was knocked out of commission by Mars. Again, very arid, dry, rocky, volcanic area. Given that we know there aren't any oceans on Mars today, just briefly, how would you go about identifying whether or not there was an ocean on Mars in the past?
I'd say clues would be like lower areas of elevation.
Okay. We would want to look for lower areas because that's where an ocean would accumulate if an ocean actually existed. But a low area by itself would not necessarily be sufficient evidence to make the case that, well, there must have been an ocean there. Jeffrey, you had something?
I was going to say minerals, in the lower areas there must have been a different mineral composition than the higher elevation.
Okay. So one of the imprints that an ocean could leave on the landscape is, oceans generate sediments that are characteristic of oceans. It could be partly the mineral composition. Could be just the structure of what we find in these lowland areas. Tristan, you have something else?
Yeah, what he said.
Okay. So, geologically, the only way we can really address this is to say, would an ocean 4 billion years ago on Mars have left some telltale signature in the rocks, in the landscape, that we could still pick up today? I mean, basically, Functionally, an ocean is just a big body of water sitting in a depression on the land, right? And so we've already said, well, maybe the sediments, maybe the minerals. What else is going to be characteristic of how an ocean is going to interact with the surrounding land?
You would want to look for like wear patterns or erosion patterns.
Okay. So oceans, especially if it's an open water ocean and there are winds on Mars, there are going to be tides. Mars is not going to have the same, an ocean on Mars is not going to have the same tidal fluctuation that the Earth's ocean has because Mars's moons are dinky, and that's a technical term. They're not large, they don't have enough gravity to really pull massive ocean tides up on Mars, but winds would generate currents and waves, and those waves would crash on the beach. We might see dune beach kind of formations from the erosion that those waves would generate. And so that's basically the approach we have to take to know to see if we can find evidence today that 4 billion years ago there was enough water pooling on Mars to create an ocean. We have situations here on the Earth that we can use as guideposts. If you look out west, there used to be, during the most recent ice age, much larger series of lakes than are present today. Some of you might be familiar with the Bonneville salt flats. Nobody is interested in cars and racing and land speed records and okay, interesting. Okay.
Yeah, before like everyone got fired.
Exactly.
Yeah. So all these other ice age lakes you're not going to hear about, but land speed records were set on these salt flats that are the remnants of Lake Bonneville. So basically, as the ice age terminated and the west dried out, all of these lakes, most of these lakes evaporated. You still have the Great Salt Lake as a remnant of Lake Bonneville. And what's going to happen to the materials that are dissolved in the water as these lakes dry out?
They're going to stay.
They're going to precipitate. And in the case of the Bonneville salt flats, they have precipitated out in this very, very flat, very level, very compacted surface that, if you're going to run a car and call it a car and keep it on the ground at, I don't know what the land speed record is these days, 400 and some miles per hour, with rockets shooting out the back of your quote-unquote car, you're going to want a space that is flat and compact, and that's why they use that Bonneville area.
763 miles an hour.
Okay, 763, thank you.
I was set in 97 by the British Royal Air Force pilot. I just take that out of it. I'm sorry.
That's okay. That part's not critical for today's talk.
Yeah.
So. But if you do look out in these areas, not only do you see things like these salt deposits, getting back to Jeffrey's point about what kind of minerals, what kind of deposits and sediments might you expect from a dried up ocean, but talking about some of these other factors of the wind-driven waves, you can identify things like these benches that are surrounding the basin where that mark out where the water level used to be, and you can look for things like that. Yeah.
Looking at the valley networks, would that be a good way to map out where possible, large bodies of water are just based on where they're going?
Yes, in a way that we'll talk about in a little bit if we get further on in this. Okay. So if you look around Salt Lake City and Provo, and these other areas of Utah where Lake Bonneville used to be, you can identify in aerial photographs, if you ignore the roads and so forth that have been cut through the landscape, you can identify things like this structure here, which you can maybe see in the undocumented image on the left. It'd be a little bit more obvious if I turn the lights out, but I'm not going to bother. But you know, this was a shoreline for Lake Bonneville at some point. You would see a shoreline appearing at any point where the lake level had stabilized at a given level for long enough that the wave action around the perimeter of that body would cut the shoreline. And so you can actually see, as these lakes dried out, they didn't just gradually dry out. There were periods of drying and then periods of stasis. And so with Lake Bonneville, there were varying lake levels that were held for a while as the lake dried out, and then there'd be the next period of drying, and the lake level would drop down to a new level, and it would hold there for a while. And you know, as long as the lake held at a given level for long enough, it would cut these shorelines around. And that'll be important when we talk about Mars, because there are actually multiple shorelines, potential shorelines, that have been identified. Speaking of which, here's the situation on Mars. Again, this happens to be in the Cydonia Plains, and we're not going to get talking about Face on Mars again, but it's in that kind of area. And if you look carefully in this image, you might be able to pick out this faint line that, from orbit, kind of looks like those fossil ancient shorelines that we see for Lake Bonneville. Okay. So some of the first argumentation about you know, the potential for there to have been an ocean on Mars was from, again, looking at these landscapes from orbit and carefully peering over tens of thousands of images and identifying structures that look like they are analogous to the kinds of shorelines we see for lakes and other areas that have dried up on Earth. Won't go into this in detail, but a whole string of these potential shoreline structures have been identified from orbital images somewhat circling that lower northern lowlands area that we've pointed out several times. You know, as we have talked about in the past, if there were an ocean on Mars, where would you expect it to be? In the northern lowlands. Okay. So for these structures to be the fossil shorelines of an ancient ocean, you would expect a number of things from them. For example, let me go back out. Can you have an ocean that only has the west side and not the east side? That's kind of a stupid question, right? If there are shorelines on the western side of the Pacific Ocean, that implies that there must be shorelines on the eastern side of the Pacific Ocean. You can't have one half of the ocean without the other. Okay, so ideally you would have these structures identified from orbit would, in the perfect case, form a complete closed surface around the whole basin, right? Why might we not see that today, though?
Wind erosion.
Yeah, some of the fossil shorelines might have been eroded, so we might not see a perfect, complete closed basin. But you know, if we only saw one stretch of shoreline over here, and we didn't see anything else, that would not be a very strong case for an ancient ocean on Mars. And the fact that that shorelines have been identified in all of these areas going around this northern lowland area begins to strengthen the argument that these are the result of there being an ocean there in the past. This is a view of Mars you don't probably see very often. This is looking down on the North Pole, looking at those northern lowlands in kind of a somewhat squashed projection of the northern hemisphere. You can see Olympus Mons over here. Here are the northern two of the Tharsis Montes. So here's Pavonis Mons, and I always forget whether it's Scraeus or Arcia Mons that is in the northern hemisphere. But anyway, here's the North Pole, and this northern lowlands area is this kind of flatter area that we've talked about in the past. So, much of this work was done by one individual, Parker, who actually started this work as a graduate student. So here's the case of a graduate student in his research really going against the grain, because at the time no one really took the idea of an ancient ocean on Mars seriously. Okay?
How long did it take?
Well, a graduate student project, it would typically take 5, 6. I took 8 years for my PhD. But, yeah, I mean, he obviously worked on this for a long time, and he identified what he thought were 2 contact levels. A lower one, or an inner contact, which is sketched out here. These are the areas where he saw morphological features looking down from orbit that looked like areas where waves had been, lapping on the shore, or strand lines, or the kinds of things that we see around dried up lake basins here on the Earth. And then he identified an outer contact layer. It was here, and part of it over here, and here, and so forth. So there is some evidence, but clearly these are not totally enclosed, perfect basins that he's got evidence for. I mean, why don't we see any shorelines over here? I mean, we should put that in a different color. Why don't we see any shorelines here or here? What's going on? Well, as we talked about, maybe the evidence has been erased in those areas due to a variety of factors, erosion and so forth. Over here in particular, this area clearly probably has been influenced by the rising up of the Tharsis Bulge and all the kinds of erosion and change in the landscape that might have generated. So he had some interesting evidence, but it wasn't complete. It wasn't completely convincing, and he was a lowly grad student anyway, and so
At least he passed.
what?
At least he passed.
Yeah, he's done all right. Here's just a more oblique view of these 2 contacts. The area that he identified as contact 2, the inner one, and then this outer contact, which is a little complex in spots. There's some evidence that sort of goes along with this idea. If you look at the craters in these northern lowland areas where he was projecting or proposing that there was an ocean basin, you see these very striking morphologies where the crater seems to have dredged up a thick slurry of stuff for the ejecta around the crater. This is what we typically see when an impactor punches through the Earth, Mars' surface, and hits a layer that has a lot of ice in it. what's going to happen to the ice in the subsurface area when it gets hit by a meteor or a comet fragment screaming in from outer space? It'll melt. Okay, we're going to be dumping a lot of heat into this area. The ice is going to melt. The rock's going to fragment into dust. Water and dust together make mud. And so you see these kinds of craters where you get an impactor coming in, punching through, and throwing a lot of thick, muddy slurry out around the crater. Okay, so the fact that these craters in this area are almost all this kind of rampart or pedestal crater formation really indicates that there's a lot of subsurface ice in this area, which is what you might expect if there had been an ocean and parts of the ocean just kind of froze as Mars got colder and drier. You also see in this area morphology called patterned ground, where the ground gets broken up into these polygons and smaller polygons. This is actually an example from the Earth, and I guess this is Mars and this is from the Earth. But you get this kind of cracking when you've got freezing and thawing going on, and so the presence of this patterned ground is also a good evidence for a lot of subsurface ice and water in these areas. If Parker was right and those were actually ancient shorelines, this would be a good example of where that ocean would have been located. And from that, and knowing the topography of the ground, you figure out how much water would have actually been in that ocean. Now, this is not Earth-like, let's cover 70% of the planet with ocean. This is much more restrained and restricted compared to the situation we have on the Earth. But if this is actually the case, it would be actually a significant amount of water. This just shows how different levels of the ocean would translate into the amount of water that would be there. So, you could theoretically have a very small ocean around the North Pole that wouldn't include much volume of water. But if indeed not only the contact 2 that Parker identified, but also contact 1 were actually ancient oceans, then that would be enough water, if it were spread out over the surface of Mars, to cover Mars to about 750 meters, 3/4 of a kilometer. So that's a fair amount of water. Just take it from me. Yeah. If you took all the water on the Earth and spread it out evenly across the Earth, it would be more than this, but not substantially more. So then how to actually test it? So Parker's basically proposing a hypothesis. He's saying, I see structures, they look like an ancient shoreline. I'm going to hypothesize or propose that at some point there was an ocean on Mars producing those shorelines. How would you then go and test that?
Comparing it to Earth's older shorelines might be the best way because we can't really get to Mars.
Yeah. That's pretty much what he did, though, already to identify these areas. So he's taken these structures on Mars look like ancient shorelines on the Earth. That's going to give me the basis for proposing this hypothesis. But to actually test the hypothesis, he or somebody else has to go to different data and make new predictions. So if these shorelines were actually shorelines, if these structures that he's identified on Mars were actually shorelines, what would you expect about their elevation?
It would be around the same elevation.
everything that's on contact 1 should be at the same height, right? Because, like, again, we don't have the western side of the Pacific Ocean a mile higher than the eastern side. There's a little variation in height with the prevailing winds. The trade winds do tend to pile up a little bit of water more on the western side of the Pacific Basin than the eastern side. But if all of these areas he's identified as contact 1 were the leftovers of an ancient ocean shoreline, they should be pretty much at the same elevation, the same height. Same thing for contact 2. And so here is the actual, I mean, once we had the MOLA instrument in orbit collecting elevation data at a very high precision, we actually had the ability to test that. And that's what's shown down here in this lower figure. So let me blow it up a little bit. Okay. So what is plotted here is the elevation measures. So these researchers took those structures that Parker identified as shoreline and said, okay, we can measure what their elevation is. So let's do that. And you see here the blue dots are for contact 1, or contact 2, that innermost series of shorelines that Parker is proposing. And the reddish triangles are the data points for contact 1, the outer set of shoreline structures. So, do these data support Parker's idea or not?
I'd say contact 2 is pretty good. I mean, through like the, before you get to like the Tharthus areas, it seems like it stays pretty low.
Okay. So contact 2 is clearly much more in line with this idea that if these are shorelines, they should be the same elevation. Contact 1, the data are all over the place. And so we really have no convincing evidence that contact 1, even though those structures maybe look like shoreline, we've got no convincing evidence that there was actually a large ocean out at that contact 1 layer. But the data for contact 2 are much better. There are some areas where some of those ancient fossil shorelines are higher in elevation than we would expect. But if you look, this is about the area where the whole Tharsis bulge pushed up. Okay, so a lot has happened in the last 4 billion years. And same thing here, you know, this, so the data, these data are much more convincing that contact 2 represents the shoreline of a smaller ancient ocean, but the evidence for contact 1 is really just not convincing at all. So that's one line of evidence. I just want to quickly go through another line of evidence, which is someone else has taken a whole different data set, looking at a different structure. And these structures that are looked at in this paper are specifically structures that look like river deltas. And this is a little bit more recent work as well. So if we had rivers flowing into an ancient ocean on Mars, which some have called Oceanus Borealis, which was in what is now the Vastitas Borealis area. Borealis just means north, so this is just a fancy way of saying the Northern Ocean on Mars. If there were rivers from these valley network systems flowing into this ancient ocean, what happens, say, when the Mississippi River flows into the Gulf of Mexico? What kind of a structure do you see there? You see a delta. You know, the Delta Blues area. Okay, so as the river is cutting down through the land, it's going to stay in the channel that it's cut. But when it gets down to where the ocean is, it's not going to continue cutting down in the ocean basin. It's going to hit the water of the ocean, and the river's going to slow down, and it's going to just drop all of its sediment in the area, and it's going to form this delta. And so delta structures themselves can be good markers of where river went into ocean. And somebody talked earlier about looking about how we can take these valley network systems and see where they would have. So that's basically what these authors did. This is just more of a cartoon graphic of the whole hydrological cycle. And again, we can look for delta structures, and we would expect to see them if we had a valley network, i.e. river system, dumping into a lake or dumping into the northern sea on Mars. Now, any of these deltas that are dumping into the northern sea on Mars, how should they compare in elevation? If you looked at the Rio Grande River flowing into the Gulf of Mexico and the Mississippi River flowing into the Gulf of Mexico, and you compared the height of the deltas for those two river systems, how should they compare in elevation?
Should be the same.
Should be the same, because the Gulf of Mexico is the same sea level all across the Gulf of Mexico. But these deltas that might be in lakes that are not connected to the sea, they could be at any elevation, right? They could be much higher. So the researchers are going to be looking for these delta formations in aerial, in global images, satellite images on Mars, and using, again, the MOLA data to determine what their elevation is. This just shows you some images of deltas. The only one I really want to point out is this. This is a very striking delta image that is actually fairly reasonably well known. This is Eberswald Delta in Eberswald Crater. This was one of the potential landing sites for the Curiosity mission, but they eventually decided to send it to Gale Crater instead. But it's clearly an extensive river delta where a river system of some kind dispersed out into Eberswald Crater and formed this delta structure. Okay, so here is some of their data. They have identified 52 delta deposits in these images. I forget what they were using, whether they were using the Themis camera or if they were using HiRISE, but they could, find deltas and categorize their elevation. And there, you can see there is some variation there, right? There's some that are as high as here. You got others that are, in this area. But if you look specifically at those deltas that they've marked with these red squares that are adjacent to where they would expect that ancient ocean to have been, those deltas are all pretty much at a fairly constant elevation. So again, this provides pretty strong support that at one point there was a substantial ocean in the northern hemisphere of Mars where a variety of different river systems dumped into this ocean, forming these deltas. These closed deltas would have presumably been rivers that dumped into more isolated lake basins, into various craters and so forth. And so they can be at varying elevations depending upon where those craters were that the rivers were dumping into. So this, I won't go into this in detail, but essentially the variation in elevation for these deltas that are associated with the ancient ocean, that's about the same variation in elevation that you would have for deltas that are dumping into any of the oceans here on the Earth. Okay? So there is some range in elevation of the Mississippi Delta versus, the Mekong River Delta. But that variation in deltas on the Earth is pretty much the same variation in elevation that we see for these deltas on Mars. Okay. So if you take this data, we have an ancient ocean on Mars that is covering about 1/3 of Mars' surface. So again, it's not the 70% ocean water planet that the Earth is, but it's not insignificant. And if there was an ocean, and rivers, then there was liquid water, it was warm enough, and that presumably has some implications about whether or not life could have evolved on Mars 4 billion years ago. Now I'm going to pretty much end it here, but I do want to switch over to the other computer and pull up a YouTube clip. There's been some recent research looking at using a completely different set of evidence to estimate how much water Mars has lost over the last 4 billion years. And this just came out within the last few weeks and made a pretty big splash in the news. So, and NASA's actually put together a fairly good clip on it. So